Hello guys, welcome to AI Basics channel. So in the last video we seen about gradient descent and how gradient descent works and what are the problems what are the problems occur in gradient descent and how to overcome those problems, and we seen the vanishing gradients and exploding gradients also, what are those and what are the techniques to overcome those pitfalls, all those things. So in this video we are going to implement the code in Python. Let's have, now we are in the Jupyter notebook. So first we need to import the basic libraries. So I'm going to import some required libraries. Import numpy as np, import as pd, import matplotlib.py as plt. Next, from matplotlib import style. Next, style dot use 538. Finally, let's import the warnings also. Warnings dot filter warnings. Like it's ignore the warnings if any warnings came. Those libraries are loading. So when you are importing those libraries for the first time, so it will take some time to import those. So I'm again going to take the salary dataset as we took in the previous videos. So first we need to load that dataset. Salary dataset equal to pd dot csv salary csv salary dataset dot head. So here we are working with one independent variable and one dependent variable for simplicity. And next we need to split into x and y. This dataset x equal to salary dataset years of experience. I'm going to take x variable as a years of experience and the y as a salary, and that means we are going to predict the salary based on the years of experience. Y equal to np dot array salary dataset and I'm going to store the total number of instances are there in our dataset. That means number of examples are there. L equal to of x. About 30 examples in our dataset. Now we need to split our dataset into training part and testing part. So I'm going to import the train test split function from SQL library instead of using our custom train test split. If you need to know how custom train test split functions works, means you can check out my ML playlist. In one of my video I explained about train test split, how the process is going on in the train test split function. Let's import the train test split function from sklearn dot model selection import train test. The next thing is we need to divide these things into x train, y train, x test, y test. X train comma x test comma y train test split x comma y comma random state equal to 32. lx equal to of. So we are going to use this lx also in the algorithm. So I saved that variable also. I assigned that variable to the total length of the training dataset. Next, we are going to the main part. Now we need to apply the gradient descent algorithm to this dataset. So the first thing is I'm creating four variables. One is slope, and another one is intercept, and another one is learning rate, and final one is number of iterations we want to iterate. I'm initializing the slope to some random number. So for simplicity, I'm directly assigning this m variable to m variable with 0.1. Instead of that, you can use np.random.int function, and you can assign by using that also. And I'm assigning this c also, something, any number you can give, that's not an issue. But one thing I want to say is, when we are assigning the weights to some random numbers, in this case you can give any number, but in the case of neural networks, in the case of in deep learning, when you don't initialize these weights to 0, because at the end of that model you will end up with same thing. Like that means all layers find the pattern same thing, so your model won't work if you initialize all weights to 0. So don't do that. Try to initialize with other than 0 number. And the next thing is alpha. Alpha means here learning rate, like how much speed we want to converge, like that. 0.01 I am giving. Finally n equal to number of iterations, 4000. Like you can modify it also later. Now create for I in range. Here I am creating again two dummy variables. One is slope and one is intercept. Here we already created, but I want to create dummy variables. So you will know shortly why I am creating dummy variables. Slope equal to 0. Here I am opening again another loop for j in range. This inner loop is for taking the example from the training dataset. So lx. So first we need to calculate this thing. 1 minute formula. Theta naught means intercept and theta 1 means here actually m, but we can call it as a weight also, slope or something. So first we need to calculate the intercept. The formula is 1 by m into summation of m times into predicted minus y original. First I'm doing this thing, and I will later I will divide with the m. Here m means lx, total length of training examples, equal to intercept plus slope m into x train plus c. This means predicted value minus y train of j. Sorry, here also j only, not I. Okay, then we need to find slope also similar way. So what is the slope formula? Let's check. 1 by m into summation of m times of predicted minus y original into x. Okay, slope equal to slope plus m into train j plus e minus train of j finally into x train of j. Now we need to divide it by m. So here the thing is, here we need to subtract, for example, take intercept value c, intercept means c equal to c minus alpha into, now we got right that intercept divided by m. We have to do that. So c equal to c minus alpha into intercept divided by lx. And similarly we have to do it m also, for m also, m equal to m minus alpha into slope divided by lx. So somewhere we got error. Root object is not callable. Sorry, here we have to keep into. Okay, let's check our slope value and intercept value. Int slope is m, and intercept is, we got slope is 9661 and intercept is 25227. Okay, then let's predict over the values. It equal to n p dot m h plus c. And finally we have to plot these things. So this is our line. In the x-axis y number of years of experience, and in the y-axis salary. So let's check our error also. So nearly we got more than 95% accuracy. So this is the idea of gradient descent and how to implement this gradient descent using Python. And another thing is I want to say is you can make this algorithm in more productive way. And that means you can get rid of one for loop and you can make more automate. Like that, when you have more than one independent variables, you need to reshape those things. So I suggest you that try it on your own, so you can get some insights and you can get practice and you can get know what errors are coming like that. For example, I'm showing the like this I made it little more productive, like little more automated than the what I have written now. So this why I should took this means because we are in learning stage, so we can easily understand the concept, so I made it simple. So in the next video we will see how to overcome this gradient descent when our gradient stuck in the local minimum, like here stuck at the local minimum. So how to overcome this local minimum problem. So we will see in the next video about this alternative technique for this gradient descent. Okay guys, thank you guys, I will see you in the next video.